A mole is a unit of amount. Just like a dozen is 12 of something. Do you know what a baker's dozen is?
13.
13 of something. What's a pair? A pair of socks. 2. Do you know what you call 500 sheets of paper? 500 sheets of paper. It's a package of paper, printer paper that you buy. It's called a ream, R-E-A-M. So we have all of these words that mean numbers. So a mole is also a word for a number. It's just a very large number. It is
Oh no, there's a long line.
602 followed by 21 zeros.
Holy.
What?
That's a lot of zeros.
That's a lot of zeros. So 7 groups of 3 zeros. That's a mole. Now, if an atom was a pea, a green pea, and we had this number of peas, it would cover 250 surfaces of the earth with peas 1 meter deep. That's how many it is. Okay, so it's an extremely large number. But because it's so large, it's not a practical unit for us to just use. So we're going to write in scientific notation 6.02 times 10 to the 23rd. And it's a count, so it's got an infinite number of significant digits. It is an SI unit, just like kilogram is the SI unit for mass. The mole is defined against a known standard, carbon-12. If you're talking, you're not listening. It is the number of atoms in exactly 12 grams of carbon-12. So the mole, the symbol for a mole is a small n, and the units are MOL. When you write this value out, you're going to include a number and the unit MOL. And I want you to get used to writing all of your units for your numbers. So it's a very important quantity in chemistry. It's a unit that represents the amount of entities or particles of a substance. Chemists deal with extremely small entities like atoms and molecules, so we need a number to make counting them practical. So instead of saying there's 6.02 times 10 to the 23 atoms, we say there's 1 mole of atoms. Okay? So 6.02 times 10 to the 23rd is also called Avogadro's number. Avogadro's number, in honor of Amedeo Avogadro. He was a physicist, but he did a lot of work with particles. It is the number of particles in 1 mole of a substance. So Avogadro's number is the number of particles in 1 mole of a substance. So we have a symbol for Avogadro's number, and it is a capital N, subscript capital A. So it is a capital N with a subscript capital A. Drop down, lower. Superscript is above, it's an exponent, subscript is below. The units are particles per mole. Particles per mole. Particles per mole will change depending on the type of particle you have. So, a particle will be substituted with a different term depending on what substance you're dealing with. So, we've got two types of elements, monoatomic and diatomic. Your diatomics are H2, N2, O2, F2, Br2, Cl2, and I2. Those are your diatomics. If you have a diatomic element, like one of these, your particle will be called a molecule. We have an abbreviation for it, and that is molic. So, if you are any other element, you're monoatomic. So give me an example of any other element. What'd you say? Oh, you didn't say anything? What did you say? Lithium. An example, lithium. I thought somebody said calcium. Lithium. And if you are any other element, then your type of particle is atom. The abbreviation for atom is atom. No abbreviation. Molecular or covalent compound. Anything. Somebody. Molecular.
Oh, I always mix them up.
One, H2O. The type of particle will be a molecule. Short form, again, molic. An example of an ionic compound, sodium chloride. The particles for an ionic compound are called formula units. And the abbreviation for this is an FU. Carbon tetrahydride. What will be the particles for this? Is it monoatomic, diatomic, molecular compound, or ionic compound? Molecular. So, Avogadro's number will be 6.02 times 10 to the 23rd molecule or molic of CH4 per 1 mole. That's Avogadro's number for methane. You don't have to write the 1 for the 1 mole, but it will come in useful later. What do you think? What's going to be the particle? Tell you what, I'll narrow it down for you. It's either molecule or a formula unit.
I always mix them up.
Mr. Simon, saying hey today.
Bless you. Okay. Relating particles, moles, and Avogadro's number. So these are actually related. N is the number of particles. So if you see a question that says how many, they want to know big N, the number of particles. Small n is mole. And Na is Avogadro's number.
No, because I can pause.
How many? Oh, let's go back to how they're related. These are related mathematically. The number of particles is equal to the number of moles times Avogadro's number. It's supposed to be an A. If you're somewhat math challenged, and some of us are, there's a magic triangle you can use. For a magic triangle, you cover up the letter you're trying to find, and the remaining two letters tell you the math to do. What math do you do when you have two numbers beside each other? Multiply. What math do you do when you have a number above another number? Divide. So if I want to figure out the number of particles, I'm going to cover up big N. That leaves little n times Na. If I want to find the number of moles, I cover up the little n. That leaves big N over Na. Okay. How many molecules of water are there in 2 moles? So which letter did they actually give us in the question? Small n. They gave us 2.0 moles. The substance in the question is water. So is it a covalent compound or an ionic compound? It's covalent. So Avogadro's number has molecules. So we are looking for big N. Big N. So N is equal to small n times Avogadro's number, 2.0 mole times Avogadro's number, now if you have a unit on top and on bottom, they cancel. So our answer would be 1.204 times 10 to the 24 molecules of H2O. Now, how many significant digits can we have in our final answer? So 1.2 times 10 to the 24 molecules of H2O. So you have to look at how many moles you have for your sig figs. Your test book is going to say what amount of carbon dioxide. If they're asking what amount, they mean how many moles. What's the symbol for moles? Is it big N or little n? Little n. So how many moles is what we want to find? That means the 1.8 times 10 to the 24 is big N. We always know Avogadro's number. Now, carbon dioxide, is it covalent or ionic? It's for particle or moleic per mole. So we're looking for small n. So it's big N divided by Avogadro's number. Two sig figs in your answer because 1.8 times 10 to the 24 only has 2. So dividing by a fraction is the same thing as multiplying by the inverse, flipped over fraction. So here, molecules would have canceled. Your final unit is mole. Here, molecules cancel. Your final answer is 1 over mole. So mole is your final unit. We're dealing with iron, which is an element. So what are the particles? Atoms, thank you. So we've got atoms of iron for 1 mole. What is N? Of course, they're all N, but what's big N? So, big N is equal to small n times Na, 0.50 mole, times Avogadro's number. For those of you that can do this without a calculator, that's half. So our moles canceled. So, how many significant digits can we have in our final answer? You have to go to the number that is not Avogadro's number. So our number of moles. How many sig figs in 0.50? 2. The 5 and the second 0 count. So our final answer is 3.0 times 10 to the 23 atoms of iron. 4.0 moles. We've got Avogadro's number for water. So what is the particle if we're talking water? Molecule. Okay, so we're looking for how many? Okay. So, big N, small n, Na, 4.0 moles times 6.02 times 10 to the 23 molecules of water per 1 mole. So that is moles cancel. So 2.408 times 10 to the 24 molecules of water. Did we answer our question? No, because it wants atoms of hydrogen. So this is kind of a throwback to yesterday. What's the relationship between hydrogen atoms and a water molecule? 2-to-1 ratio. There's 2 hydrogen atoms for every 1 molecule of H2O. So that's another piece of information that we know. If I multiplied my answer by this ratio, what happens to my molecule of water? It's on the top in the first, and it's in the bottom in the second, so it cancels. So my units that are left are hydrogen atoms, so now I just have to do the math. 2 times 2.408 times 10 to the 24 . So there's my number of hydrogen atoms. So sometimes it's a 2-step problem. You have to look at the substance you have moles for to figure out the particles, and then go back, is that the same question I'm being asked for? If not, you need an extra step with a ratio. So, how many significant digits can I have in my final answer? 2. You're right, 2. So 4.8 times 10 to the 24 hydrogen atoms. Now, do not ever round early. Do not round the number of molecules of water and then multiply that by 2, because sometimes it introduces rounding errors. So if you're going to use a number again, don't round it off. Okay?